system. In education system, the biggest problem is one human being coming and telling another human being, how many times I should tell you? Still you have not understood that. That's the worst thing in an education system.
One for linear and one for, so one you make it for linear and one you make it for rotational. So the first point I'll take is position. In case of linear, the positions we generally take it as x, means position is nothing but the distance. Whereas in case of rotational, the position we take it theta. Correct or not? Why? Because if linear means what? If a body is there, say body 1 is moving with some speed and say it have got this much distance. If this is the linear, we say this distance is x. Whereas same body 1, if it have rotated about theta, so this is what? Theta is the change. Here x is the change, whereas in case of rotational, theta will be the change. That's why for linear the position will be x, whereas for rotational the position will be theta, that is x and theta. Similarly, let us go to the second part, that is velocity. Here velocity will be v for linear, whereas the velocity in rotational will be omega. So it is called as rotational velocity or angular velocity, where omega is nothing but 2 pi n. Then we have acceleration. Acceleration over here is given by a, whereas in rotational it will be given by alpha. Similarly, the fourth point, if you take it as motion equations, this will be given by x is equal to v t, whereas here theta will be given by omega t. So from here we can derive three equations, that is v is equal to u plus at, then s is equal to ut plus half at square, and this is v square is equal to u square plus 2 as. Correct? So this is the equation we can form from this, where v is the final velocity, u is initial velocity, s is distance, t is time, and a is acceleration due to gravity, or you can say g. Correct? Similarly, in case of rotational, the equations will be with respect to omega, because omega is the angular velocity. So this will be omega 0 plus, here it is alpha, right? So alpha t. Similarly here theta, that is the distance, will be this, that is ut plus half alpha t square. You can see the relation here. S is theta, means the change in linear is nothing but the change will be theta in case of rotational, whereas here omega square, omega 0 square plus 2 alpha and this is theta. This is the motion equations of rotational kinematics, right? Here we are talking about what? Here we are talking about kinematics of particles. So this is the case. So now fourth is done. Now the fifth one, we'll go for mass. In case of linear, the mass will be given by m, whereas in case of rotational, the mass will be given by I, which we generally show by mk square or ma square, right? Similarly, the sixth one, I should better change the color. This is m, this is I. Then the sixth one, we go for Newton's second law. According to Newton's second law, how this can be derived, how this can be mentioned. This can be mentioned as F is equal to ma as per second law, whereas this is tau is equal to I alpha. Then momentum. For momentum, P will be mv, whereas L will be I omega. Similarly, work over here will be F into D, whereas over here it will be tau theta. Next, for kinetic energy, in linear equation we generally show it by half mv square, whereas in case of rotational we show by half I omega square, correct? Similarly, power, one more part is power. So power we can show over here is, if you go for power, that is the 10th part, power for linear and rotational. So for linear, the power will be force into velocity, whereas for this will be tau into omega, where omega is velocity and tau is the force, torsional force. Clear? So this is how we basically differentiate with kinematics, and we go across. Say for example, a question is asked based on the same thing. Say for example, a one-year question have been asked. I'll better take the question. This was a GATE questions. This was a GATE question in 2004. They have asked a rigid body. I'll better mention that. Okay, so those are the important notes. You keep it. Here, question was asked. GATE, that a rigid body as shown has a mass of 10 kg. There is a mass, like there is a body which is hanging on a beam, and this is the mass. This mass is 10 kg. Okay, and this distance is 0.2 meter. Clear? Here question is asked, if it rotates with an angular velocity, if it rotates with an angular velocity, say omega, if it rotates with a uniform angular velocity omega, a balancing mass of 20 kg is attached as shown. Now here this is one case. One more case is there, the same. Here this is 10 kg, and here again, here in place of, you can see here in place of this, here the position is fixed, and on the other side there is a mass, that is, this will be the mass. This is a question given. and the distance from here to here it is 0.2 meters, and from here to here it is 0.1 meter, and the mass of this is 20 kg. Question it is asking the percentage. What question is asking? The percentage increase. So for the first case, when you go for the solution, for the first case what it is? I is equal to ma square, that is m is 10, a is 0.2 square. Whereas in the second case, I is equal to ma square, that will be for two cases, correct or not? What are the two cases? It will be ma square, that is 10 into 0.2 square plus 20 into 0.1 square. So in this case we get the value of I as 0.4, whereas in this case we get the value as 0.6, that is mg meter square. Okay, sorry, kg meter square. This is kg meter square, right? Now this is the change. Question is asking what is the percentage change. So increase in percentage will be what? 0.6 minus 0.4. The base is 0.4 into 100. So this will be 50%.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way learning. Download our revolutionary app for free AMC.